and saying, hey, it works. But remember, if it doesn't work in any of them, it doesn't work in the whole thing. I'm not sure how tricky they exactly made it. They might have made it like, oh, it doesn't work in any of them. But technically, it only needs to fail one for it to fail the entire system, because the system is asking, where do all of these meet? Are all of these the same? Let's get back to section 7.3, the weird stuff. You guys were saying number 42 was weird, and number, okay. What was the odd one, 27? 37, okay. So we'll look at that one in just a second. But number 12 was pretty normal. Although the book would do it a little bit differently. I mean, they're doing their whole nice little paragraph, whatever. Oh, and number 12 is already in row echelon form. That wasn't bad, yeah? That's not bad at all. Number 22? Did you guys not have it? Okay, but he was just two variables, two equations. He wasn't like a weird two equations. I get it. So the two variables, two equations, yes, you could have substituted, yes, you could have eliminated, but this was just showing that our system works for this as well. If you had taken these two equations, eliminated the x's, you would have had a stair step, and it's very similar, just kind of, I know it's a problem that you could do multiple ways, but just kind of showing you the system works for the small ones also. But then number 42, 42. Was a bit of a beast. But before we go over that one, let's talk about your 37, because you had to do that one first. Number 37, let me go steal him just because it'll be faster probably than me writing it out and you guys like dictating it. It was a system of 3 equations though, right guys? Yep. Oh, wow. Huh? Here we go. Did you figure out the system last night? Not figure it out per se, but did it at least become the procedure that you were using? If it's no, then I get it. You're a human. You're creative. You can make up your own way. The problem is if you make any mistakes, I just am not going to be able to find it for you in class, because we could have literally done this like not 30 different ways, but probably at least 5 to 10 different ways. And I can't show you all 5 to 10. And to be honest, you don't want me to show you all 5 to 10. So if you were following my system yesterday, what 2 equations are we working with first? 1 and 2. And hopefully all of us as humans, if we're doing 1 and 2, our goal is to eliminate the x's. Wouldn't most of us have just multiplied this guy by -3? Right? I mean, you could multiply him by 1/3. You could have, but most of us would have multiplied by -3. So I would do equation 1 minus 3 times equation 2, which would have gotten us to, if you guys don't mind, since this is homework and you've had time to already play with it, and then do it the fast route. And you can keep me honest since you have work in front of you. So 3 minus 3x, that cancels out. That's the point. -3 minus 6 will be -8y. 6 plus 3z will be 9z. And then 6 minus 15 will be -9. Double check me.
It's not 8.
-3 minus, oh, 6. Thank you. -3 minus 6. Ooh, so I could just be lazy and divide it all by -9, or maybe that's not lazy. But then most of us, wouldn't we then, if you're in keeping with my system, then tackle the next 2? But for the next 2, I think most of us would probably just multiply him now by a -5. -5x plus 5x cancels. -10y minus 8 will be -18y. 5 plus z will be plus 18z. And then -25 plus 7 will be -18. So what happened when you, let's see, that was -5 times equation 2 plus equation 3, in case you're wondering the little baby formula of what I'm doing. What's our goal after we eliminate x's in the first 2 and the second 2? Our new equations, yeah, eliminate y's. So most of us just unless you got rid of the -9 and got rid of the -18, you would have just been like, just multiply him by -2. So you would have -2 times equation 4 plus equation 5. If we were to write a baby formula once again for that elimination process. Which if you guys notice, 0 equals 0. Why is that a bummer? What were we trying to find? Z. We were trying to find Z because our whole purpose was to be able to, we're humans, we can be creative. I'm going to steal this equation from my first because he looks way better than the others. You guys maybe would have done that, maybe not. I would divide everybody by a -9 to make that guy pretty, which would be y minus z equals 1. The problem is I was supposed to, if the system worked, careful, the system did work. If the system of equations was consistent and only had one solution, I was going to get a z equals number. But you guys noticed yesterday, I was being very purposeful in what I showed in your notes. Because in your notes, when I was writing up like our process of what we were doing, I think I kind of showed z equal to a number and then yz equal to, but I kept it general. And for us to be even snazzier, it might even be helpful for us to change in our notes. Let z equal a. Now usually we get that to be a number. That's totally true, but in 37 it wasn't. And the reason it wasn't was because it was one of these weird cases. Now I know it's going to be weird. I'm going into the third dimension for a bit. It's going to be one of these weird cases where the solution, there are solutions. It's not that there are no solutions. There are solutions, but it's not one single x, y, z point where 3 x, y, z points are coming together. It's not a single x, y, z point. It's a line of points. It's more similar to this solution. It's a whole line of points. And if it's a whole line of points, well then, to be honest, if z was that vertical axis, remember I said some people put x, y down and then z comes up. Z could be any number. But if z is any number, there are only certain x's and certain y's where it will work. So how do you show infinitely many and yet very specific? Not infinitely many as in all, but infinitely many as in this particular line alone. That's what this process is for. Now, I don't remember where I was doing it. Maybe I saw it. Oh, you saw me. To that end, all we have to do is say, we don't know who z is, so whatever, z is a. And that's why a is true. Because this says true, this says infinitely many, but not everywhere, only in a certain location. So how do I define that certain location? Well, I say, all right. I'm not going to be able to put 1 point, but I can say for any z, what's y going to be, and for that y, what's x going to be? We substitute, we back substitute, saying, I know z can be anything, but if z is 1, y can only be. If z is 2, y can only be. If z is 3, to show that math, all we got to do is plug it in, plug it in. So if I plug in a for z, add it to the other side, y is equal to 1 plus a. And once I have a, I can plug in for z. Once I have 1 plus a, I can plug that in for y. And I can go ahead and solve just like I would with numbers. It's just going to take a little more work because I have variable expressions instead of minus. And then get x alone. So I have my 2, I subtract, that'll be 3. I have my 2a minus 1a, which is 1a, and then I subtract. And pretty quickly, I have all the pieces to fill in. Now here's the tricky part. Depending on what you set equals an a, this could look different because you could have an a here, and then that would kind of move. You could have an a here, and then that would kind of change. Like it could look differently and still represent the exact same infinite set of numbers. Or I think I saw in some problems, probably more in tonight somewhere, if they have fractions they don't like, they might just multiply everybody by like a common denominator and get rid of the fraction. Kind of like we did with substitution and elimination sometimes. Like we multiplied decimals by 100 to get rid of decimals, and multiplied fractions by the common denominator to get rid of the fraction. They could do that here also. They could make it prettier. But this one, there are no fractions. We let z equal a. I'm pretty sure. You guys can give me a thumbs up. Was that what they had in the back of the book, the way they wrote it? For 37? Yeah. You guys just get 37? You're going to make people look in the back of the book? Really? An entire class? Okay, thanks for these opening. What happened there? Negative a plus 3, 1 plus a, and a. So some of you guys might get confused. They didn't write it exactly like this, but check it. Is it the same thing if they write it like this? Any different? Okay, addition to disappointment. But besides that. All right, number 42 then. Are we ready to go grade? So hopefully it makes a little more sense as to why or as to how all of a sudden they have phased out. I'm going to zoom in just a little bit because I realize that bottom part where it gets messy might be a little hard for you guys to see. But number 42, they're doing elimination with 1 and 2. They're actually writing it out because we know them. They write it all out. But they got rid of the x's to get this guy. They got rid of the x's in equations 2 and 3 to get that guy. Then they use these two to get the next guy. They're kind of keeping it in matrices, whereas I'm going off to the side and coming back. Matrices. Okay, remember, we're getting there. We're not there yet. They're kind of keeping it. We took out all the variables of the matrices. Then they got that 0 equals 0. They let z equal a, they just didn't show it. They said, oh no, we only have this? Okay, fine. We'll just go ahead and solve to get a leading coefficient of 1, reduce row echelon form. Solve to get a leading coefficient of 1, and then they say plug in, if z is a, plug it in, solve, and then plug both in and solve. There again, they chose to be human. They didn't use a computer necessarily to do this, which means they chose the equation they thought would be easiest to solve for x. And they were totally right. Just subtract the a divided by 2. So realize you could have totally written this a few different ways. One way I can think of right off the top of that is that you could have had 5 minus a all over 2. Same thing. Same thing. And actually, if you didn't like that, you could have multiplied everything by 2 and then just not even had any fractions at all. But they left it in those fractions, and that's fine. Okay, anything in last night's first part of section 7.3 besides 42 that we got stuck on? Yeah. 29. Anything else besides 29? Oh, which one's that? 55? Okay. So looking at 29 and 55 real quick. 55 was in section 7.1, yeah?
Yes.
And 29 was section 7.2? Oh, it was the same one. Okay, got it. Thanks, Spencer. I didn't realize there were 2 of them. This right here is the reason we follow the system. If you went about it a unique way, you might not be able to find your mistake from mine or me doing it mine. I would do a -2. And then we would have 0 plus the 5y minus 5z equals 25. Now we'll take these 2, but multiply by a -3 instead. 5y minus 5z equals, ooh, this is interesting. It's another unique one, but it's a different type because we have 20. This is last night's homework. I believe this was 7.3a. There were 2 different 29s. So this isn't the 29 that you went back to 7.2 for. This is the 29 that was in 7.2. 27 plus 5, is that 32? But why is it weird? I mean, guys, look at it. You see it, right? If I go to do elimination right now, what's going to be bad? Well, that cancels. If you distributed the negative, that cancels. But what doesn't cancel? So what's the other special case? If 0 doesn't equal 0, if it's not true, if it's false, what can I say right now? No solution. Yeah, but it's is the problem different than you had? No. I'm double checking real fast. I think I have a -3. You just forgot to distribute the negative, I believe. Because when you distribute the -5 minus, and then -5 plus, and then 25 minus 32. So 32 was the bigger one. But the nice thing is, either way, you know that your final solution is this. Be careful, a little mistake like that. But in this one, you should have gotten the same no solutions. But yeah, good double checking. So, nice thing about no solution is, now here's the tricky part. Can I show you that picture again with the third dimension? Just real fast. It doesn't mean that there's no intersection at all. It means I could put my hand down through it and be just fine. All three don't intersect. Maybe two of the other ones do in a line, or these two do in a line. Maybe all of them do. But the fact of the matter is they don't all come together in any point or line or plane. So that's how I can tell. Even though there might be some intersection, there's no place where they all intersect. Spencer, is that good? Cool. All right, guys, we do have another homework. If you guys want to write it down quick, some of you go to Google Classroom, but I do have it right here also. Check it. We have literally 7 homework problems. That's it. I'm not saying they're all weird. I'm not saying they're all hard, but a couple of them at least will look even different than what you've seen so far. So we're going to go back to our notes and do a couple more examples so you guys are ready. But only 7 problems. If you want to take a quick picture, you totally can. And once again, remember, the book is just walking you through whatever it is they're doing, which you might do, you might not do. You are a human, you are creative. We're not forcing you to be a machine. I'm just trying to keep you within a certain procedure so that when we come together, we can all be like, oh yeah, that's what I was doing in general, and did I do it right? So I think the system is important, even though, like, they decided to switch to equations, cool, sure, do what you want to do. I mean, you can do. Remember when you go to Calc Chat, they might have done something a little bit differently than you, but you guys should be following the same system as long as you follow the take 1 and 2, eliminate x. Take 2 and 3, eliminate x. Take the next 2, eliminate y. Where are you at? No solution, infinitely many, or an answer to solve. Yeah, Kayla, sorry. Okay, so as we get back into our notes, I did have, 37, we ended up doing a different way. We ended up doing in the snipping tool. So let's get back into, we're good. There we go. Let's get back into notes and basically just talk about what's the weird stuff you're going to see tonight. And once again, it's not the whole homework. I'm just saying it's going to show up. Back into notes, same section, 7.3, just for the second homework from 7.3. All right, Brandon, here we go. It's okay. I know. It's a struggle. 7.3. Don't need a new table of contents or a new page. Just keep on going. What is weird about number 44, which is basically where our homework stops? Or at least it's skipped. Only 2, but how many variables? And if you know anything about systems of equations from Mr. Che last year, aren't you supposed to have however many equations as the unknowns? Solve for 2, you need 2. To solve for 3, you need 3. To solve for 4, you need 4. Skip. No solution, we're done. Just kidding. It's impossible for 2 planes to come together in a single point. Some of you who are more visual or artistic, maybe you can think back to those 3-dimensional representations I showed a second ago. And be like, wait, 3 planes can't come together in 1 point all in the middle, but can 2 planes come together in 1 point? If you're like, I'm not visual, I don't know what you're saying, I don't know what you're talking about. Okay, hold on. 3 planes can intersect in a way that there's 1 point in common, and only 1 point. I know pink and blue have a line, yellow and blue have a line, pink and yellow have a line, but all 3 of them, only one, x equals, y equals, z equals. But imagine taking the blue out, or imagine taking the pink out, or the yellow out. Without a third plane or a fourth or a fifth, you can't come together in a single point in the third dimension. It would only be more similar to this. It would only be a line. If that's true, well then it's impossible for me to get x equals number, y equals number, z equals number. But last night in homework there were some where that was impossible also because of the way they came together. So what did we do if 0 equals 0 and we didn't have a third equation? We let z equal a. We let z equal a. So the only thing that's weird here is that you don't have, or it doesn't look like it's going to work. It doesn't look like it's going to work, but at the very beginning, if you ever see 3 variables and 2 unknowns, like, oh, there's infinitely many, but we can still show or express that infinitely many because it's not all. There are some restrictions. It's a line. What line? Well, we'll go find it. What line? We'll go find it. How are we going to find it? By doing our system. And our system says, even though there are only 2, still go eliminate the x's. I'm like, okay. Eliminate the x's. Would you guys multiply this guy by -2 and then add down? -4 plus 4 is 0. -6 plus 18 is 12y. -6 plus 15 is 9z. And -42 plus 44 is 2. Double check my math though. And here's the scary thing, guys. If we're going to nature seeds, this mental math I'm doing is going to get harder and harder for some of you guys to keep up with. Which is why in days like yesterday where I slowed down and wrote out all the equations, it's really important for you guys to write all that out. Some of you are doing mental math like me, and it's like, okay, cool, usually I'm right. Usually you're right. But for others of you, if you try, you're going to get lost. Slow it down, write the equations out, do the elimination. But sorry, all that was, am I right? Somebody caught up. Spencer.
Why is it equals 2?
Because I can't do -14 plus 44. How did I get -42? Oh, because I've done -6. I kept the -6 and multiplied. Got it. -14 and 44. Are we good? I mean, we're kind of good because we don't have the other 2, right? That's okay. We do what we can with what we have. So I'm going to make a system of equations and say, I can't go anymore. I can't get equation number 5. I can't get down to a z equals a number. But it's kind of like yesterday where 0 equals 0. You didn't have z equals to a number either. So it's like, okay, fine. Z equals a. If you want just row echelon form, you can have that 12 be in there. If you want reduced row echelon form and to get even closer to programming and matrix math, you wouldn't leave it at 12. You would actually get down to be a 1, divide everything by 12, so that way, every time you would know it would be 1y plus, you could plug the z in to whatever it was. And so reduced row echelon form, I'm trying to also have you guys understand the calc chat if you're looking at it and their steps. They would have divided everything by 12. And so you would have had 1y plus 9 over 12 is 3/4, yeah? Z equals 30 twelfths. Ends up being 5 halves. So your brain's like, I would have never done that. What? Just leave it with a 12 in. Yeah, but if you have a computer, it doesn't mind gross numbers again. And it's helpful to have a 1z, 1y, 1x in telling the computer how to solve once it gets here. And so the calc chat would probably do the exact same thing here. It would get a leading coefficient of 1, which means it would divide everybody by 2. And get something like x plus 3 halves y plus 3 halves z equals 7 halves. So it looks funny to you, but to them it's like, yeah, that's normal. But it depends. This might be actually in the next section. But this is what we call reduced row echelon form, getting a leading coefficient of 1. But the long story short is that we have to get this a guy and plug him in to get our final solution, our infinitely many solution. It's going to be long. Let me give myself just a little bit more space. But if you do this reduced row echelon form, dividing everybody by that leading coefficient in whatever equations you're using for your first, second, and third. Sorry, first and second. Third's already kind of predetermined. I already had it ready to go and set up. In that, we got that A. We have 3/4 A that could be subtracted to the other side. I'll do 5/2 minus 3/4 A, but from what we looked at in the one last night, they might write that A term first, kind of like a line. So negative 3/4 A plus 5/2. And then for X, why am I doing that? You have to actually pause and think for a little bit and plug it in. At least I would have to with all my fractions that I have. So I would take them off to the side and say, okay, sweet, well, I have my Z, I plugged in. Now I have my Y. So my X would be 3/2 A, 7/2. I like common denominators. It makes my life easier than going to a calculator, so I can make 8s out of this guy, 12 8s. I'm going to see I need to combine like terms in the seconds. I'm going to get this guy into fourths, so 14 fourths. If I subtract, I get negative 1/4. If I combine, I get 3 8s. I just need to subtract that guy over to get my negative 3 8s A minus 1/4. Mental mathers. How are we doing? Mathed up so far? But this is one that, to be honest, the book might have not been a huge fan of how it was written. So, can I just show you, just to kind of, because I'm almost positive, one or two where they try to show you the idea of it doesn't have to stay this gross. They could have also done something like let Z equal 8A. Why would they put a random 8 in there? That doesn't make any sense. Oh. What if every A was an 8A? Could some of these fractions go away? Do you see it? So there's that idea that if you have this being a little bit nicer, it might not be as gross as it needed to be. Because if I had, well, I could show it real quick. If I did have that being like an 8A instead, or even like just being maybe even like a 4A instead. When I go to plug this in, I could have said, oh, hey, so Y would equal, well, 4 and 8 reduced to be 2, 6A. Move it to the other side. Maybe it would have been a bit nicer. But some of you are like, well, I still have a fraction, though. Okay, so maybe they'll do it, maybe they won't. But there is the idea that you do have to let Z equal 1A. It could be 2A, 3A, 5A, 7A. There are times where they might change this if it would get rid of all the fractions. This one won't, though, because you're still going to have these numbers that are still a part of the answer. You're still going to have fractions that result, so maybe it's not really worth it in this one. But I just wanted to let you guys know that they could discover that it might make an easier form, a nicer form, a prettier form by making it equal something other than A, like 2A or 3A. So, back to the original question. Is there a way, are there solutions to systems that only have 2 equations and 3 unknowns? Yeah. So what did Mr. Che or maybe even your Algebra 1 teacher tell you about how you need 3 equations to solve for 3 unknowns? Is that technically true? Well, it is if you just clarify it a little bit. You need 3 equations with 3 unknowns to find any single unique solutions. But infinitely many solutions, well, we can have 2 planes intersecting in a line and we can find an equation of that line. Now, some of you are like, that's not a line, it's a weird parenthesis, comma, XYZ thing. I get it. We don't know how to write a line, a 3-dimensional line. We haven't learned 3-dimensional graphs and how to show them or show their equations. But pictorially, if we go back to that 3rd dimension visualization of what's going on, we can have 2 planes intersecting in a line where we say, let Z equal this or this or this. What would X, Y, what would X be? What would Y be? And we would have a collection of points that maybe is straight up and down, maybe is diagonal, maybe is. We could graph this if we were graphing the third dimension, but I think most of you are like, no, thank you. Yesterday in the third dimension was more than I even wanted, so let's not do anything past that. So we won't. We won't go graphing what that actually looks like. We're just kind of realizing when I have this weird like A thing going on in my solutions, it's representative of like a line or maybe even an entire plane where they are sharing points. Okay, 2 last things, then we're done. 2 last things, and then we're done. Whoa. Wait a minute. Do you even see a system? Where's my system? Has anybody gotten here in homework yet? I know we just got it like 2 seconds ago. Does anybody see a system? This first guy doesn't even have X's and Y's. What's with that? Three unknowns, 3 conditions. 3 unknowns and 3 conditions. This one's the weirdest one because technically I haven't given you guys the entire problem. I've only given you the directions of the problem, and not even with the words. The actual given information involves 3 ordered pairs, or 3 hints. Our ordered pairs aren't going to be x, y. Our ordered pairs are going to be, x is t, and y is the other guy, s. So I'm going to take these t's and s's and say, okay, they've given me the hint that when time is 1, when t is 1, my position of my object is 132. When t is 2, the position of my object is 100 feet in the air. And when t is 3, the position of my object is 36 feet in the air. Uh-oh, something's falling. Something's falling down. It's called the free fall model, something where only gravity is acting upon it, maybe with an initial thrust or an initial throw. But gravity is all that's at work. There's no little engine, no little accelerator, no little thruster or rocket attached. If I know these different positions, these different T's and S's, I can plug and check. But before I show you that one, there are 3 clues to this one. It was just not written down. I think this one's a bit more obvious. Has anybody figured out where the system is that I'm supposed to solve in this picture? The angles, x, y, and z are my unknowns. So with 3 unknowns, I'm hoping to have 3 equations. Does anybody see 3 different relationships that I can make an equation out of? And I'll give you a hint. One of them is 180. That would be cool, except it'd be really nice if we could have them written in the normal, like x's, y's, z's 180, just for sake of solving. So wait a minute, Justin was talking about 180 and this guy. Wait, how does 180 have anything to do with this guy? What does 2x plus, minus 7 plus y end up equaling because they're supplementary? So can't I make that guy? Well, I like the minus 7 over there and the y here. Couldn't that be one equation? What else? X plus y plus z. Yeah, that's kind of the easiest one, right? What else? You see it? 2x, oh, I like the 7 over here. Oh. But I also have a z? Ew, this doesn't look right. I need x's and y's and z. Oh, what am I going to do with the 7s? Send it over. So why not make this 173 and I can put the z in the right spot? And then why not make this one with the y and send that 7 over, which will make that 187. Do I have a system? Yes. Where does the system come from? Over here. I would plug in my y's, which are really my s's, and have my 132. I could have my 100. I could have my 36. But I also need to plug in my x's. And when I plug in my x's, which are really t's, you could get things like 1/2 A plus B plus S. It's going to be weird, instead of X's, Y's, and B's, I'm going to have A's and B's and S's. When I do, you guys can back up. I'm going to get my system of equations, 9/2 plus 3b. Oh my goodness, this is fun. Bye guys. You're going to get systems out of other equations and then apply what you know. Homework due Monday. If you guys need me for corrections or anything else, I'm going to be here.
I don't feel really good. I think I'm going to go home early. So,